Welcome back learners to our YouTube channel, Roboarmy. In today's video we are building our own 4-wheeler obstacle avoiding robot by using Arduino Uno. Let's start with how to assemble the 4-wheel chassis. Before we move on, first of all, let's take a look at what we'll need. We have 2 acrylic chassis frames, 4 wheels, 4 DC gear motors, 6 columns, 8 screws, 8 acrylic fasteners, 12 small screws, 8 nuts, and 1 screwdriver. Alright, let's begin. Step 1. Mounting the motors. Secure the motors onto these fasteners by using the screws provided. Do the same for all 4 motors. Step 2. Attaching the wheels. Slide the wheels on the shafts of the motors and make sure they're fixed in place. Step 3. Now tighten the columns as shown in the video. Step 4. Mounting the second chassis frame and secure it by using the screws provided. Make sure everything is tight and secure. At last, double-check all connections and make any necessary adjustments. Ensure that the wheels can move freely and the chassis is stable. Finally, our 4 wheels robot chassis is now assembled and ready for the next step. Let us see the components required. Here we have an Arduino Uno, which will act as the brain of our robot. Next, we have the L298N motor driver for controlling the motors. 1 ultrasonic sensor mounted over a bracket. This sensor uses sound waves to measure distance and will enable our robot to detect obstacles in its path. To give our robot the ability to scan its surroundings, we are using a servo motor. This motor allows precise control of angular movement, perfect for sweeping the ultrasonic sensor from side to side. Next, we have some jumper wires for the connections. 1 double battery holder with switch, 2 lithium-ion cells, 1 USB cable to upload code to the Arduino board. With the chassis and motors in place, it's time to wire up our components. Place the motor driver here. The L298N motor driver has 2 output channels labeled as Out 1, Out 2, Out 3. and Out 4. Now pick 1 wire of motor 1 and 1 of motor 2 diagonally. Insert it in output 1 of the motor driver. Then, pick the other wire of motor 1 and motor 2 and insert it in output 2. Similarly, connect the motor 3 and 4 to output 3 and 4. Take the battery holder and paste it here. Insert this red wire with half-cut male jumper wire in the plus 12 volt slot and tighten the screw. Similarly, insert this black wire with half-cut male jumper wire in the ground slot of the motor driver. Now paste Arduino Uno here. Firstly, power the Arduino from the motor driver. To do so, insert the red wire to VIN of Arduino and white wire from motor driver to the ground of Arduino. Remove these clips. This motor driver is controlled by 3 input pins per side. Enable A, input 1 and input 2 for motor 1 and 2, and enable B, input 3 and input 4 for motor 3 and 4. Insert male to female jumper wires in these pins. Connect the Enable A and Enable B pins to PWM pins on the Arduino, which means pulse width modulation pins. Here I am connecting it to pin number 10 and 5 respectively. These pins will control the speed of the motors. Connect the IN1 and IN2 pins of motor 1 and 2 to digital pins on the Arduino. Here I am connecting them to pin number 9 and 8 respectively. These pins control the direction of motor 1 and 2. Similarly, connect the IN3 and IN4 pins of motor 3 and 4 to other digital pins, like 7 and 6 respectively. These pins will control the direction of motor 3 and 4. Let's move on to the servo motor. This motor will allow our robot to scan its surroundings. Insert the male-to-male jumper wires to the pins of the servo motor like this and insert it in the chassis and fix it. Now, connect the red wire of the servo motor to the 5-volt pin on the Arduino for power. The brown wire will be connected to the ground pin and the orange wire will be connected to digital pin 11. Now take the ultrasonic sensor with the bracket and paste it over the servo motor like this. Take male to female jumper wires and insert them in these pins. Now we'll connect the VCC pin of the ultrasonic sensor to the 5V pin on the Arduino board for power. The GND pin will be connected to the ground pin on the Arduino. Next, the trigger pin will be connected to digital pin 4 and the echo pin to digital pin 3. Now check the connections according to this circuit diagram. With our circuit set up, it's time to write some code. Before we move on, let's understand the logic for this project. The ultrasonic sensor should measure the distance to an obstacle. If an obstacle is detected within 15 centimeters, the robot should stop, move backward for a short duration, and then stop again. The servo will position the ultrasonic sensor to scan left and right to measure the distance in both directions. The robot will compare distances to the right and left. If the distance to the right is greater, the robot will turn right. If the distance to the left is greater, the robot will turn left. If no obstacle is detected, the robot will continue to move forward. So now, download the code file by using the link provided in the description below. Open the file if you've already downloaded the Arduino IDE, otherwise download the Arduino IDE first. Here you can see, we include the necessary libraries for controlling the servo motor and the ultrasonic sensor. These constants define which pins on the Arduino are connected to the motor driver. These pins are used to control the direction of the motors. These pins are used to control the speed of the motors. These pins are used to trigger and receive the echo from the ultrasonic sensor. Here are some other variables. Maximum_distance is for maximum distance the ultrasonic sensor can measure. Goes forward is for a boolean to track if the robot is moving forward. This distance variable is to store the distance measured by the ultrasonic sensor. Here we have created objects. Sonar initializes the ultrasonic sensor with the specified pins. Servo_motor initializes the servo motor. In the setup function, we configure the pin modes, attach the servo motor to a pin, and initialize the distance measurement. Set the motor control pins as output. Attach the servo motor to pin 11. Initial distance measurement. Position the servo motor to the center. Measure the distance multiple times to initialize the distance variable. The loop function continuously checks the distance measured by the ultrasonic sensor and decides the robot's movement. If the distance is less than or equal to 15 centimeters, the robot stops, moves backward, and checks the distance to the right and left. The robot then turns in the direction with the greater distance and resumes forward movement if no obstacle is detected. These functions control the robot's movement and measure distances using the ultrasonic sensor. Look right function and look left function to measure distances in the right and left directions using the ultrasonic sensor. Read ping function is to measure the distance in front of the robot. If no measurement is returned, set the distance to a high value, 250 centimeters. Move stop function stops all motors. Move forward function moves the robot forward by setting forward pins high and backward pins low. Move backward function moves the robot backward by setting backward pins high and forward pins low. Turn right function turns the robot right by rotating one motor forward and the other backward. Turn left function turns the robot left by rotating one motor backward and the other forward. That's it. Now, we have to upload the code to our Arduino. Connect Arduino Uno to computer via USB cable. Select the correct board and port in Arduino IDE. Click the Upload button to upload code to Arduino. With the code uploaded to the Arduino, it's time to put our robot to the test. Insert the batteries to the pack. Switch it on and watch as it navigates and scans the surroundings using the servo motor and the ultrasonic sensor. When it detects an obstacle, it calculates the distance and moves around it using the motors controlled by the motor driver. I hope you found this tutorial helpful. Don't forget to like, share, and subscribe for more awesome projects like this. Thanks for watching, and till then keep learning.